Today, some of you might remember seeing these things a long time ago. Those are the replacement brakes that I painted back in, I'm gonna say it was the 2015. So that's been over 3 years now. And inside my crate is calipers, wheel bearings, brake pads, wheel cylinders. I've got spring kit for the back and assorted tools and things that I'll need to go through this truck and completely replace the brakes. So once I'm finished this, it will basically include a new master cylinder. I'm still waiting on some flex lines that I ordered. They are going to be stainless steel, upgrading from the original rubber, and all new brakes all the way around. So this thing should perform much better. I've made some room. We've got the Blazer in the barn now, so that should make working on these brakes much easier, because now I'm not fighting the weather and whatever may happen with that. Let's get this thing lifted and up on blocks so I can get all four wheels out of here, out of my way. Have to move a couple of things to make a little bit more space, but I should be okay here, and for the most part I'm on the concrete. But once I get my blocks underneath, we'll be able to get this thing up on the axle and sitting and safe to work on. So okay, well the truck is up on its blocks now. It's pretty stable. Shouldn't give me any troubles. I got a big beam under the pumpkin with an extra spacer to keep the drive shaft from having any extra twist to it. Alright, I'm going to show you guys how to do the brakes. This is a 93 S-10 Blazer. This is two-wheel drive. It has ABS brakes in the front. Other models will be very similar to this, with a few specific part changes related to four-wheel drive, like a different rotor. However, this is the gist of it. Pretty straightforward here. So I've got the vehicle up on blocks, and it's safe right now. So we're going to start by removing the tire. For some of you who may not know, I'll give you a quick rundown here. This is the rotor, the part that actually rotates. On this particular model, the wheel bearings are housed inside of this rotor. So when you pull this off to replace it, you're exposing the spindle, which is what the rotor sits on and spins. In my scenario, I'm also going to be updating and replacing wheel bearings. They've been on there for as long as I've known, for as long as I've owned this vehicle, and I'm thinking, hey, it's time to replace it. Seeing surface rust on the rotor is normal. That's not something to be concerned about. The truck's been sitting here for the night, so having that is kind of a common problem. When you look from the top down, you can see how much pad life is actually left. This pad is getting close to the end of its life. So there's still a bit of life left in it. I don't necessarily have to change these right away. Even the rotor itself, there's no scoring on it. It's not worn down excessively, so this could be turned and reused. So I'll probably keep this rotor, have it turned, and then I'll put it away for another set for another time. The caliper is this portion here, and that's what's actually providing the squeezing force to stop that rotor from turning. On the front of the rotor itself is just a dust cover, and inside there you're going to find a nut with a pin through it. By removing that nut and pin, this whole rotor will slide off the spindle. But before we do that, we have to take the caliper off of the spindle. And that caliper is on a mounting bracket, and there's also pivot bolts, or slide bolts, that have to come out here as well. And that's the ones that run through the back of the mounting bracket and allow that caliper to actually slide. So I think what I'm going to do next is pull out these pins. I've turned the wheel a little bit just to get a bit of a better line of sight here. The pins that roll through there are a 3/8 hex head style, like an Allen key type. So these should always be kept well greased. Using something like anti-seize is going to help you out big time when it comes to replacing these components. You can actually see the copper color paste that's still intact on this slider. So that is from the last time I did the brakes. That would be the remnants of the anti-seize that I had been using at the time. When these bolts are starting to get stuck and don't want to come out, that's where applying a little bit of heat may be beneficial. However, if you're keeping the same caliper and intending on reusing it, you're going to want to be very careful with how you heat this up without overheating something or burning parts. There we go. So now we can remove the caliper from the rotor itself. Just like that. Super easy. Attached to the caliper and the vehicle is the flex line. That's what the brake fluid has to run through in order to activate this cylinder to provide the clamping force to stop the vehicle. So you do not want to just let this hang from that flex line. You don't want to bend and kink this thing or twist it up a million times. I'm actually replacing the flex lines. I'm going to be installing new ones. The originals were rubber. I can still use the same rubber ones if I chose. However, I'm going to be upgrading to a stainless steel style line. And what that does, these rubber flex lines have a tendency of swelling a little bit when you apply the brake. And that's completely normal. That's totally fine. But that gives you a bit of a spongy feel when you're pressing the brake pedal. So by changing these to a stainless steel braided style line, you get more resistance to swelling. So what that's going to do is it's going to make that pedal feel much firmer when you activate the brakes on the truck. Since I don't drive this truck very often, and I do enjoy kind of a sporty sensation with it, and I think providing that upgrade to the brakes is going to be something that to me is worth it. That's not required for everyday driving. It's purely a preference if that's something you're interested in. So we're going to worry about this caliper later on. For now, I'm just going to leave it up on the upper control arm out of my way. And you can see the brake pads here. This is the outer brake pad, the inner brake pad. They haven't really worn equally, but that's quite alright. There's still some material left. They still have some life left in them, but I'm not going to be using those again. They've expired as far as I can tell. Another thing to mention too is these sliders inside of the caliper, sometimes you may have to press those out and reuse them. They are supposed to float freely inside of that caliper. Mine are, they do move a little bit here, but with my finger I can't just quite push them through. But that's something to keep your eye on. Your new caliper may not have those installed, so you might have to knock them out of the old one before you can put your new caliper on, if that's what you're doing. So I'm going to let that sit up out of my way. We're going to turn this wheel straight again, and I'm going to show you how to remove the rotor and the wheel bearings. So now I have to remove the dust cover. You can use a chisel or a flat blade screwdriver, a little bit of light tapping, and you'll see that pop away pretty quickly from the rotor. And I'm hardly using any force here. Just like the weight of the hammer is enough to pop this free. And you can buy these for replacements if you choose, but they're totally fine to use again as long as it's not all smashed up. So there we go. The cover is off. You can see the inside of this is all covered in grease, but that's the intent. Your wheel bearings are in here, and you want to make sure that that's going to stay well greased to help keep that spindle and those wheel bearings lubricated, keep moisture out of there, and help with a bit of heat dissipation. So, let me get a rag, wipe out some of this grease, and we're going to look for that pin that goes through and holds the nut in position. Alright, so I can see that pin passing through in this direction, and the end of the pin is bent over to keep it from backing out. That's the ideal scenario here. So I'm going to gently bend that pin so it's able to be slid out. And I'm just, again, tapping very lightly. I'm not being aggressive with this at all. Okay, so we can see that pin is free. Look at that. Here we go. So that goes in my pail of things that I'm going to keep. And now we can remove that nut. So the nut that actually holds the rotor and wheel bearing in position, it doesn't actually have to be very tight. It needs to be snug, and it needs to absorb any play that's in those wheel bearings. I'd have to look online again, but I want to say the torque spec for it was something like 12 pound-feet, which isn't very much at all. So we're going to remove this nut for the spindle, and we're going to keep it because, again, we will be reusing this. My threads are in good condition. There's no signs of rust in there, so that means the grease kept the moisture away and did its job. So this is that nut. I'm not sure if it's called a crown nut or a king nut or some kind of a nut. So now the rotor can actually be pulled off of the spindle. There are some washers here. So the first is an outer washer, and this actually retains the wheel bearing, the outer wheel bearing in position, and it has a built-in keyway that fits on the spline on the spindle to keep that from rotating. You can see that keyway there. So this is a pretty important washer, so you're definitely going to want to use that again. You're going to have no choice. The outer wheel bearing is right here, and we're going to look at that in a few minutes. So now I can pull this rotor straight off of the spindle carefully. And there we go. In the back of this rotor is the rear wheel bearing. There's also a seal that's hammered into this to help retain this grease and keep it in position so that wheel bearing isn't just going to pull out. It's kind of stuck in there. And this gear looking portion on the back of this rotor is how the ABS system works with this truck. It's got a sensor that's mounted to the spindle, and it's ultimately reading that gear as the wheel turns. And if it no longer sees a signal coming from this wheel, it knows that the wheel is locked up, and then it would activate the ABS system. So some of you may not have that gear on the back of your rotor, but that does not make a difference. It's just an additional feature that this vehicle has. So now we're down to the spindle itself. We want to check the condition of the spindle. In order to do that, we need to clean it and look at it. We need to look for wear marks, gouges, things like that. So I'm just using my greasy rag that I've been cleaning the bearings with to remove the surface grease and see what we've got. So I used a bit of brake clean. We cleaned off the spindle here just to have a really good look at it. There's no wear marks on it, there's no pitting, there's no scratches. So that means that my wheel bearings were doing exactly what they needed to do. They were mounted snug enough to be in position to operate correctly and not cause me any troubles. If you see damage on that spindle, you usually have to replace the spindle. That's a pretty crucial point where that's mounted to the vehicle. You don't want that to be compromised. This certainly needs to be strong. It's literally responsible for holding the wheel to your vehicle. You can buy spindles for this S10. These happen to be 2-inch drop spindles. So the spindle's actually positioned a little bit higher than what it would have been from the factory, which gives the vehicle a lowered look. I've also got 2-inch lowering springs on the front of this truck as well, for a total drop of 4 inches in the front. So these are the front replacement rotors that I've had since about April of 2015. They've been sitting in a closet for a long time. They were painted a long time ago. The only difference between the stock rotor and this one, these ones are slotted. Whether or not it makes a difference physically with performance, I'll be surprised. If anything, it just gives it a different look. The paint also does that too. So we've got two main components to look at here. We've got the outer wheel bearing, we've got the inner wheel bearing, and then we've got an oil seal to accompany them. Let's start by opening these up and having a look. Now these wheel bearings come with an outer race. In my scenario, the outer race has already been pressed in on both the outer rotor, the inner rotor and the outer rotor. That race has already been installed. So this particular part and component we're not going to need. I'm going to dry fit these just to show you the process involved in getting this together. But it is a tapered fit. So they basically drop into position, and that's how they seat. And you can see how that bearing operates on that spindle. The spindle goes through the middle of this bearing and gives you a low friction rotation. Then the last piece of our puzzle here will be the oil seal, which will eventually be installed flush with the surface on the back of the rotor, and we'll use a socket and a hammer to gently position that and install it. We're not going to do this until we have the wheel bearings properly packed. If you've never done this process before, it's pretty simple, and I'll go through the details with you. We have to grease these bearings and prepare them for installation. If you install this with no grease on it, it's not going to last very long at all. It's going to overheat with no lubrication, and they're going to burn up and seize. Very similar occurrence would be if you had ran your engine without oil. It would lock up. So let's get to packing these bearings with grease and installing them, and I'll show you the process involved there. So I've got some general purpose grease. On it it says it's good for disc, brake, wheel bearings, steering linkages, chassis, suspension, universal joints. So this is the perfect product to utilize for wheel bearings in this scenario. Provides lubricating protection, 0 to 375 Fahrenheit. So we're happy here. This is GM Chrysler, European, Japanese vehicles is all purpose. Now what we want to do is get the grease inside those passages of that roller bearing and pack that area completely full. We want to get as much grease in there as possible. So we're going to use clean grease, clean new grease, and what I've found for me the best scenario is to take a scoop of grease in my hand and actually press the bearing into it and try to work it into those passages slowly as I'm rotating it. I'm trying to fill all those voids up. This is a messy process. You will get grease on your fingers, your hands, and anything else you touch. That's where the gloves come into play if you want to try to keep your hands clean. So this is a bit tedious, so I'll save you the boring details and I'll fast forward through this, but I think you'll get the idea. So just so it's understood, this is the rear seal for the rotor's wheel bearing. And this surface on this seal actually is going to ride on the very back end of the spindle. So when that rotor is installed, it fits up and over this shoulder and ultimately makes a seal to keep the hot grease in place on that rotor. So if you imagine it being reinstalled on the rotor, that's going to give you a bit of assistance in trying to figure out which way this thing has to face. You want this to go straight on to that sleeve, so you actually install it face up, facing away from the back of the rotor. And you tap that in so it's flush with the surface of the rotor. Using something like a socket, a much larger socket would accommodate this better, but you can use something smaller if this is all you got. And then you gently tap it into position using a hammer or a mallet. Slow and steady, and you'll get that in position. Don't forget to install your wheel bearing first. Once you press that seal in position, you can't get that wheel bearing past that opening. So I put some clean grease on the spindle, which is again important, and I made sure I greased the back plate where that oil seal sits against. Let's get that rotor in here. So this rotor has the outer wheel bearing installed, the inner wheel bearing, and the oil seal. And now that slides on the spindle carefully. And then we start with the washer that's got the keyway cut in it, and that should help us seat those bearings properly. And then we're going to take that king nut and begin threading that on. And you want to make sure that everything's going to operate smooth and clean. I'm going to give this a bit of a turn here. Feels nice and smooth. So I've got this king nut set right now so I can put that retaining pin in there without any troubles. That passageway is clear. So I'm going to go ahead, wipe off the old grease. I don't want any dirty, contaminated grease in there now that it's been repacked with everything clean and fresh. So that pin's in position. And I will use my channel locks to put a bend on the end of that pin so there's no way it can back out from that nut. So now we're looking at the dust cover. And would you look at that? I cleaned the inside of the dust cover out. Again, why would I put dirty grease back inside? Brand new Raceway with bearings, nice and clean in there. So this is nice and snug. So I'm actually going to put some clean grease inside this cap, and that's to keep some moisture away. And then I'm going to gently tap that cap back into. Alrighty, I think we're doing pretty good here. We need to clean this rotor off with some brake clean. You can see there's some dirty fingerprints, some grease on it, and you definitely don't want to contaminate those brand new brake pads. So you get yourself some brake clean. Follow the directions on the can and get that rotor clean. My new calipers have the slides already installed. They've got brand new pins, which is excellent. And they've never been filled with fluid before, so they are completely dry. They're also labeled. We've got R for right and L for left, as they are specific to that side of the vehicle. If you're unsure, refer to what is on your vehicle currently. In my scenario, on the front passenger side, this one here would be the right side of the vehicle. It's stamped with an R. So, okay, perfect. One quick, easy way to figure this out as well. The bleeder screw is normally going to face up. When this caliper is installed, that bleeder screw should be at the highest point. The reason that happens is to aid with bleeding the brakes, to help get the air out of that system. So let's choose our right side caliper, since that's what we're going to load up first. It's got some fuzz on it from sitting in the house for so long. And we've got some brand new brake pads here. These are ceramic by Wagner. So it's kind of an upgraded compound from what the factory brake would have had. So on this setup, we've got an outer and an inner pad. The outer pad has some bottom fingers that fit into that caliper and essentially lock it into position so it can't be moved from that position. The inner pad has a small spring retainer that's fit onto the back of the pad and then pressure fit into the piston in order to hold it into position, like so. I've taken the dowel pins out. I'm going to clean them. These are the new ones which have just been painted. And I'm going to grease the slides on the back end of this caliper to make sure that everything's going to operate as it should. I've got a little bit of grease that has come with these brakes, or maybe with another set, I'm not even sure anymore. But I've also got some anti-seize to provide some extra protection on those threads. And sometimes inside the head of the bolt is a good place to put a bit of anti-seize if you have the option as well. So I'm going to go ahead and get this mounted and installed on the truck. I have preloaded the threaded holes on the spindle with some anti-seize. Now I'm going to slide the caliper into position. So I've got the pads installed already on this caliper, and they will fit on each end of the rotor here. Okay, so I've got the first one started. So I've turned the wheel just to get a better visual here. But what we're going to want to do is apply some grease to this slider down here. This is that pin, or this is the location where the pin goes through and then bolts up to that spindle. So we want to make sure that that's going to stay lubricated and continue to work. So we're going to apply some grease to that. Okay. I will also apply some grease to the through bolt itself, where it rests on that sleeve. Let's slide that in. Okay. Now, I'm going to put a dab of anti-seize inside the head of the bolt for me, for later, just to provide some additional protection. So on this wheel, the hardware installation has been completed. I'm waiting for my new flex lines to arrive, and then I can connect the hard line from the factory to the actual caliper itself with my new flex line. For now, I'm not going to disconnect the old one because there's no sense in opening that hydraulic system and letting the air get to it and letting it start to rust or anything like that. I'm going to leave it sealed, and it will be perfectly fine sitting here just as is. Now I can get to work on the driver's side front rotor and get it to the exact same position as the other. So then they will both be ready for flex lines. And in the next video, I will be showing the process of replacing the rear drum brakes on this truck. In a very similar fashion, I have all new components to be installed, including a wheel cylinder, spring kit. The parking brake components I will be reusing, so those will be required to be cleaned and reinstalled. But I will show you guys the step-by-step process in the next video. So thanks again for watching, and I appreciate the views and the comments. And don't forget to hit that subscribe button on your way out. I'll see you next time.